Okay, now I'll look at the next question. For 30 to 32-year-olds, is citizenship status associated with ethnicity? Um, this question's a little trickier because we haven't, I don't know if we've created the ethnicity variable. If we have, if I haven't, I'll show it to you now. So we're going to transform from the rename or combine categories. We're going to do Latinx versus race. Um, so basically, we're going to say if anyone identified as Latinx, we're just going to call them Latinx. So what I'm going to do here for all of these categories here, I'm just going to paste them in as Latinx. So it's somewhat like, whoa, you could say this might be like an overstatement because all these people, like this person identified as Central American and Black, this person identified as Central American and is with Central American and Asian. So like all of these levels, we're in. It's a little hard. I mean, I'm not totally happy with this technique, but this is one way to do it. It basically you get a group that does identify as Latinx, but the Latinx group could identify also as other races. But now, when you have a group that is white, this group that is white does not identify at all as Hispanic. So this is non-Hispanic. And this group here that is Black is also non-Hispanic. This group here that is Native American is also, it's Native American but non-Hispanic. This group here that's Asian, same deal. So in some ways, you've now pulled all of the people who identify as Hispanic or Latinx, we've pulled them out of these other race categories. And this is pretty kind of classic treatment of how in America we deal with ethnicity or this Latinx heritage along with the race classification, because these are two different questions that are asked. So we're just going to create the new variable. I just call it like the race Latinx merge. So this is what you got to do for this one. It goes pretty fast. Once you got it made, you'll have it for the rest of the year. I've already made it, so I'm not going to create it. I already got it made. So what I'm looking at is I'm looking at 30 to 32-year-olds as citizenship status associated with ethnicity. So I'm going to go 30 to 32-year-olds. So this is another one of those situations where we have to download the data and then upload it in. So 30 to 32-year-olds. And what we're going to do, I think just for a little bit of simplicity's sakes to show this to you today, I'm just going to look at born in the U.S., not citizen, and naturalized for my citizenship status. And when it comes to my Latinx merge, I'm just going to do Asian, Black, Latinx, and white. I mean, I don't think these other groups are very large. I could do two or more races just to have it in there, but I believe these other three groups are very small in sample size. So I now have born in the U.S., not citizen, naturalized citizens, Asian, Black, Latinx, white, and then two or more races. I'm going 30 to 32 years of age. So I can now download this data as a CSV, and then I can go over to stat key, and I can go into chi-square test for association. And I can upload my file. So upload my file. And I'm going to select, I want to know if this race and Latinx merge, this ethnicity is associated with citizenship status. I'm going to let race be my explanatory variable, and then I'm going to have citizenship status be my other video. I got to finish this video. So at this point, we now have the contingency table gets uploaded into StatKey, and what happens is it calculates a chi-squared value. Chi-squared value, I'm not going to try to explain this here on the video here, but it basically creates a numerical value that shows you how much difference there are between the groups. So it quantifies the differences according to like some calculations. Calculations are not super critical to understand, but it's basically you have an expected value, observed value, and they calculate a contribution to chi-squared. What we do then is we now take this data and we do a randomization of the data. The randomization of the data assumes that all of the groups have the same percent of people who are naturalized, born in the U.S., and not citizens. So it's an assumption that there is no difference amongst these races in citizenship. So it assumes no difference at all. But differences will occur due to the sampling process. So as we do thousands and thousands of samples, we see how likely is it that we're going to get 382 here. We're going to see that 382 is just not showing up at all in the samples, in the randomization samples. So at this, we can conclude at the end of the day that definitely we are seeing an association, because the test, this is what, if there was no association, we would get something here in the black. But we would get something in the middle 95%. That's not happening. Actually, if you think about this, if I set this up to be 0.005, this makes the tail 5%. Any score higher than 15 on my chi-squared is not likely to happen by chance. So our 382, definitely very unlikely to happen by chance. Let's just show what this looks like so we can kind of compare it visually, what we see here. So I have citizenship status, and I'm grouping it by my race Latinx merge. I just want to show you how different the cells are. We should see very big differences by race. And here we go. We see for white, born in the US is at 84%. For Asian, the number's down to 34%. Latinx is at 70. 2 or more races are at 90, and black is at 82. So very big differences between Asian and kind of the white, 2 or more races are black. Latinx is somewhat in the middle. So when we go to the chi-square test and we look at the details here, we're going to see that the Asian subrace is contributing the highest scores to the chi-squared value, because they are in most difference from the overall population. And they're just changing the numbers altogether. This fact that they're different makes everything sort of kind of come off. And we probably see that Latinx probably has the least contribution, because they're sort of the average between Asian and white. All right, so at the end of the day, null is the same thing, no association. This is, alternative is that there is an association. We did construct the contingency table. I did it as a bar chart. We tabulated the data. I didn't enter the tabulated data in. I uploaded it in. It's easier to do that way. We did get a chi-squared value. Chi-squared value shows up right here. Here's the chi-squared value, 382. We calculated the p-value here on the next page. So how did you find the p-value? The p-value is how likely it is to get a number as high as the chi-squared that we got, 382. It was definitely 0. It never happened. So therefore, at the end of the day, we can conclude there definitely is an association here. The results are very firm that getting this sort of differences between the races is not likely to happen by chance. All right, thank you.